Munch. Oh, no, it doesn't work? Yes, better. Thank you. Oh, man, I never know where to put this thing. Like here, here, here. All right. Not. Whoa. Okay. I don't want to see any pizza left tonight. I really trust you that you're going to eat everything. No food waste. That's what we aim for. All right, so welcome everybody. My name is Fabio. You've maybe seen me at some other events. I've been running this event, this meetup for quite a few years now. And I'm really excited about what's coming up tonight. But there's also something special tonight. First, for me, especially. Usually, I have sponsors. But tonight, I have a partner, which is GOTO Conference, without which this wouldn't be possible. So please give me a big applause for GOTO Conferences. And Natalie's going to tell us something about GOTO and what they do and all of that. So.
How does this work? Hi, thank you for coming. I'm very happy there are as many humans here as there are. So, who of you has not heard of GOTO Conference? Ooh. Who of you has not been to a GOTO Conference? Who of you wants to win a ticket for the GOTO Conference? Did you all sign up? Yeah, everyone signed up? So if you're on the list, you can get picked. Wonderful. So what did I do?
You just went through the entire presentation.
Oh, okay. Here.
Let's start again.
Okay. What am I doing? I didn't press anything.
You must have some magical powers, some presenting powers.
Magic fingers.
Oh.
See, it's not me.
Has powers.
It's not me. Okay, I'll just tell you. So this year's GOTO Amsterdam will start June 9th and go for 3 days till June 11th. June 8th is a whole day hands-on masterclass day. They're pretty awesome. We've got amazing speakers this year. Our theme is good old plain programming, taking you back to old programming languages and digging deeper until new programming languages. And obviously, we've got AI, machine learning, microservices. Basically, we are a multi-topic conference, so we've got something for everyone. We've got amazing speakers. I'm very, very, very excited about Pierluigi Collina. Anyone not know Pierluigi Collina? No? He is one of the most charismatic, most well-known referees in football. So if anyone's the bald guy, yeah. He's awesome, and his talk is funny, entertaining, very interesting about how tech changed the role of referees. So don't miss out on Pierluigi.
And he comes from Italy.
Yeah, of course, as the name says. Well, the southern part of Italy.
Far away from
yeah, far away. We have Kevlin Henny, we have Trisha G, I never know how to pronounce it. We have loads of amazing speakers. Burr Sutter from Red Hat, since we've got the Red Hat boys here tonight. Burr Sutter apparently is a rock star, so don't miss out on him either. So have a look at the website, gotoams.nl, and Wi-Fi. I think you have the Wi-Fi on the tables, but here it is, so put it in. Do you know our YouTube channel? So basically, all the best talks, all the good talks, the ones with the highest ratings go onto our YouTube channel. So this is lots and lots of hours of information and learning, and it's free. So, So we are not the only ones partnering tonight. See, partnering tonight. We're partnering as well with Trifork. where this is the Trifork building. Trifork have the GOTO Academy, which have master classes. The next one is on reactive programming with Ole Dokuka. So get on, what's the website? Go to academy.nl? Yeah? Is it there? See? Oh, I have my glasses on. I still can't see it. So, yes, this is from me. Thank you, Trifork. Thank you, Reactive Amsterdam. It was a pleasure working with you on this, by the way.
Really?
Yes.
Wow.
So thank you very much. And thank you very much, Roel and Maxim. There you go.
Did I turn this up? No. Just a couple more slides before we start. For this conference that she just mentioned, we have a discount. Go to Reactive. It's 10%, and the conference is still happening. Anybody was signed up for KubeCon? Yeah? Who is massively disappointed? Yes. Yeah. But this one's still happening. So go check it out. And one final shameless plug. I am the organizer also of a conference that happens here in Amsterdam, still happening, at the end of September, so there's a lot of time. Ticket sales is not open yet, but the call for presentations is open. And it's called Kubernetes Community Days, obviously about Kubernetes and everything cloud native. Actually, in fact, Maxim here was a speaker last year. A lot of precedence to local content. Last year we had Albertine on stage and ABN AMRO, just as local as it gets, basically. And so please, we really are looking forward to all your submissions. Well, Kubernetes is in the name, but really anything sort of cloud native, which is all and nothing, will fit. So please go check this CFP, or maybe spread this inside your company or your office. That would be great. And finally, tonight's going to be a great event, but we have some more things in the pipeline. So one night, for instance, about Eric's Java and Spring. We're talking about reactive and scalable systems in Go in a little bit. gRPC is in the mix. So if you're not signed up to my meetup called Reactive Amsterdam, well, please do sign up. And I hope you guys enjoy tonight. So have fun. Thank you.
Edit to this deck today. Guess what it was? I replaced Solutions Architect here with Business Development Manager because I went into sales like 2 days ago. So any really hard technical questions are for him. They're for him and 3 of our colleagues that are over there. So they know the really deep technical stuff. I just forgot everything instantly overnight. So. But what we're going to talk about today is Quarkus, which is marketed as Supersonic subatomic Java. Supersonic because it's really, really fast. Subatomic because it's really, really small. And Java because it's basically still Java. And that is interesting because, full disclosure, I have never been a full-time programmer in my life. But I like learning new languages. So what I kind of do is I see something like the Rust programming language. Are you familiar with Rust? So I try out Rust, I learn enough Rust to do what I wanted to do, and then I get bored and I move on to something else. And I've tried to do Java like I don't know, at least a handful of times before Quarkus came out in my life. I always got put off by the, and that probably sounds weird if you're a professional Java programmer, but I was put off by the sheer amount of boilerplate and basically arcane knowledge you have to build up in order to become really productive in Java. And when I started playing around with Quarkus, I was like, this just works. And it does what I think it will do. So Quarkus for me it's a really big step forward. It makes Quarkus makes Java more approachable to people that just start out with programming in various ways. And we want to play around. We basically want to play around with Quarkus with you guys as well a little bit. So if you all brought your laptop today, everybody brought a laptop? Good. So yeah, I see them over there. What we want to do is we want to talk about Quarkus, and I'm saying we because Roel is bound to add something at some point to the presentation. I've known him for about 6 years now. He will. We're going to talk about 40 minutes, maybe a little less, maybe a little more, and then we have a little break. And after the break, we have playgrounds set up on Katakoda, about 50 or 75, I'm not really sure, 75. And you can basically all log into that. We have a couple of scenarios that you can play around with and learn a little bit more by just going hands-on and trying things out. So if that sounds good, we're going to be here until 9:30. If that does not sound good, we all go home at about 8. So just let me know. So let's talk a little bit. Let's talk. I'm shouting. Let's talk a little bit about what the background is of why Quarkus came to be in the first place. So are you all professional Java programmers? Who is a Java programmer? The vast majority here. So okay, good. So you all know that over the past couple of, I guess, decades, the majority of Java applications was written as fairly large monoliths running on JBoss EAP or WebLogic or WebSphere or that kind of stuff. Over the last maybe 5 years, maybe not even, things started changing. We started breaking up application into smaller chunks, using frameworks like Spring, breaking your applications up into even smaller chunks like microservices, and now moving even further towards the smallest unit probably achievable, which is a function, a single function, basically breaking up the application further and further. Eventually, you probably want to end up, or at least that's what I guess is right now the ideal picture, is in an event-driven architecture where your application only runs when there is something to do for your application, when there's an event that your application needs to handle. And a lot of these changes have rode on the wave that is Kubernetes, right? Kubernetes was the engine that started transforming those huge monoliths and what we call at this point traditional. The word traditional is weird in IT because everything that happened today was hip, is now traditional. So you can talk about traditional Kubernetes or traditional cloud-native Java applications like Spring Framework. And we're moving towards a situation where you want to package up those functions and run them in Knative. Basically, your application not running unless it needs to do something. So Kubernetes is really the engine behind this change in the market, basically. Now, Quarkus really focuses on making the life of people easier that are in this side of the slide, basically. Maybe a little bit here, microservices, serverless, that's the sweet spot for Quarkus. Monoliths, probably not. If you really want to re-architect your application, rewrite your application using Quarkus framework, you probably can, but you might want to split that monolith up into smaller chunks first and making it, APIs that talk to each other, basically. The way Quarkus works at a high level is by still being Java and giving you the ability to generate native binaries by using Graal VM. Is everybody familiar with Graal? Just a few people. So in the context of Quarkus, and I'm not going to go really deep into this, but what the role of Graal is in the Quarkus framework is to take your Java code and do a lot of compile time optimization instead of runtime optimization, and creating really a native binary, an ELF binary on Linux. And that ELF binary starts really, really fast and has a very small memory footprint. So you get an application that you just drop into the smallest, tiniest container you can get and run it 100 times on a single node because the memory overhead is just tiny. Does that make sense? Cool. Now, we want to make, and when I say we, I obviously mean the community at large, but there are a fair amount of red headers in there. So we want to make it very easy for people that are familiar with the Spring framework to get started with Quarkus as well. So we're trying to to bring a lot of the to try to bring a lot of the Spring libraries into the Quarkus framework as extensions, meaning that you can just use them and the extension will make sure that you can actually still build the native binary out of your Spring framework libraries in your application. We already have quite a few. You got Spring dependency injection, you got Spring MVC already usable in Quarkus 1.0. I'm not really sure if Spring security is already in there. We're currently at Quarkus 1.2.1. I'm not really sure if we already did that one. And Spring batch is currently under discussion to be added to the Quarkus framework as well as an extension. So you don't have to learn a whole set of new skills. If you're familiar with Spring, it's very, very easy to get started with Quarkus as well. You should start coding, start trying out whether your application still works. And one of the scenarios that you can play around with later on when basically everybody opens up his laptop and you start playing around, one of the scenarios in there is getting started with Spring in the context of Quarkus. So if you're a Spring programmer, I invite you to give that a go. By the way, I love getting questions. If I am not getting questions, it means I'm talking to you guys for 45 minutes. Might be a little bit nicer if it's interactive, so feel free to ask questions, and I'll happily pass them on to Roel. There's one over there.
What is still missing, or the big things from Spring missing still in Quarkus?
That's a good question, and I'll happily pass it on to Roel.
Repeat the question as well.
Oh yeah, the question is, are there any large chunks of the whole Spring framework still missing in Quarkus? And I honestly do not have an answer to that.
I don't know if, yeah. Switch it on?
You sound really close to me.
Normally I don't need amplification. Yeah? No, with the top. This works? Yes. Okay, cool. So, as Maxim said, we are embedding some of the, well, what actually happens is that we implemented the Spring annotations into the into Quarkus. We started obviously with the, I'll start moving, or it's him again. We embedded the most common one, so we started off with the normal Spring bits, and as here on the slide, right, it's basically the dependency injection annotations, it's the MVC part, Spring data as well. Are there things missing? Unfortunately, yes, because there was only so much time we had, and we happily accept pull requests if you feel really motivated. But it is something that we're building out on, and actually at launch we already had a couple of, well, I can't call them customers because they're not paying yet, but users of the framework in production, and based on that feedback we prioritize which libraries will come in. So Spring Security is one of the first ones to go in. Spring Batch is under discussion. There's actually not that many people using it at the moment, so the feedback is, stop moving. The feedback is not there yet, but aside from these, this is basically at the moment it. And one of the things that we're also looking into is some of the streaming and cloud functions kind of stuff. But you'll see that most have an alternative that is actually Spring independent. So like the integration with Kafka, the integration with a lot of the other things, but Maxim will cover those in a later slide. Hook me up later if he didn't cover what you needed. Yeah? Cool.
Good. Thank you for that. As far as I'm concerned, you get extra points for the raffle by asking questions. I'm not in charge of the raffle, but I'm going to say it anyway.
Chocolate.
Chocolate?
Yeah.
Chocolate?
In front of the laptop.
Oh, but
Give him chocolate.
you want a chocolate? You can pass that through to the gentleman in the back who asked the very good question. There is more. So,
What's the name?
sorry? What? Anywho, to give you a bit of an idea of what happens when the Quarkus optimization takes place, generally when we build an application, when we have the Java JDK, Java compiler build an application, there's a lot of stuff that still needs to happen at startup time, right? Java does a lot of stuff when it builds, and then there's a lot of stuff that still needs to happen when the application actually starts. Think about things like parsing config files, scanning your class path, basically preparing for really bringing that application up. And there's a lot of stuff that happens, you know, if you guys are familiar with the inner workings of Spring, a lot of the starting up of the Spring application uses classes that are afterwards never used again. So they just remain in memory and they're just consuming bytes and bits, and they're not actually functional anymore. So one of the great things that Quarkus does is moving that stuff into build time. So all of the dead code that you would have when you start your application, you know, when that stuff happens at start time, all of that code is gone because Quarkus already did it. Quarkus already took care of taking out all that dead code. So the memory footprint of this application, when built with Quarkus and built with GraalVM basically, is much, much smaller. And I'm naming GraalVM now, but it's not entirely true, but even if we are not using GraalVM and we're just using the Quarkus compiler, the Quarkus framework itself, the memory footprint and the startup time is still much, much lower than a traditional cloud-native Java stack.
Yeah, if I don't want to get stuck with Oracle, what would be the alternative to GraalVM?
Yeah, that's a very good question, and I know. Yeah, sorry, good point. But the question is, if we do not want to use an Oracle product, basically referring to Oracle's stewardship of GraalVM, what do we have? Right now, I don't think you have anything, to be honest. I think there is. That's why we pass it to Roel again.
Yeah, no worries. If you want to go full native, then the answer is yes, you're still tied into Oracle. We're in discussions. There's multiple routes that we can take. Which one is not finalized on. At launch of the supported stack of Quarkus, because obviously Quarkus at the moment is a community released project and a community supported project, Red Hat is going to support this commercially as well. At launch, you'll have just between quotes, the ability to run as a hotspot VM Quarkified image. It'll give you some benefits. We actually have a couple of the launching customers or the launching users of the Quarkus framework in production right now are already using it in that fashion. And some of them went to Oracle and because they have an ELA and got Graal anyway. Either way is fine with us. We're looking into what we can do to also offer either a similar offer or maybe even Graal under the stewardship as we did with the Java framework itself over the past years. But to just come back to the question, so we have two ways to work with Quarkus. One is just compiling it to a native image that will require Oracle, or you build it as a hotspot image, and then that is your alternative if you want to use Oracle stuff.
Mm-hmm. Okay,
Yep.
I knew this. I thought you had something really new. The thing is, in a couple of slides, I have some metrics about memory usage and startup time for both traditional cloud native Quarkus without GraalVM and GraalVM, and you will see that GraalVM is actually, it's a lot leaner still than the Java version, the JVM version of Quarkus. But JVM version of Quarkus is much, much smaller and faster than the traditional cloud native Java stack. So there is still a lot to be gained by using Quarkus without GraalVM. And you know, we want to do this, well, we're Red Hat, and I hope I'm not crossing any boundaries here, but we want to do this the right way. We're an open source company, we do stuff open source, and we generally want to do stuff in open source projects that have good stewardship. So we really want, you know, we're really working hard to find a lasting solution for this. So this is, let me put it this way, it's not over, right? We really want to make this work. Anyway.
One more question?
Sure.
Where's my chocolate?
Good point, good point, good point. There you go, kind sir. Good point. I'll go to my chocolates like...
That's the 3 bars behind you.
Ah, very good. Good. This work? Okay. So as I already mentioned a little bit, what Quarkus is, it's a framework to build your application in a really optimized fashion, and it delivers you a ton. I think we have over 80 extensions at this point. So there's a ton of extensions already built into the Quarkus framework, and you just enable with a single command. And what those extensions will do is they will make sure that if you want to use Hibernate, if you want to use REST Easy, you want to use any of those libraries that you're used to using, those extensions will make sure you can actually fit them into your native image. You can actually do the right way of reflecting on your code, and you get the small jar afterwards, and not the big one with all the dead code in it. So again, there's a lot to be gained by using Quarkus without having the Graal SDK as part of your build process. Go ahead.
The disadvantage if I don't use the Quarkus extension, but say I link directly to Vertex, is that the final image will be bigger because I input a lot of US code?
The way I understand it, and I haven't looked at the code, and I haven't tried actually building applications with libraries that are not part of an extension. But the way I understand it, you might get the optimized code, but there is no guarantee. Nobody's tried to make this work and tested it and optimized it to make sure you can actually get that very small native image and a very small optimized jar. Everybody get the question? Back? Yeah? Okay, good. Question over there?
So there's this three dot 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 at the end.
Yeah.
These extensions, are they sort of Red Hat governed or?
No, there's no Red Hat governance on the extensions. What we have is a community that provides access to a whole set of those extensions. I can show you a list. You can just get a list from Maven. If you type the right command, it will show you what is available. And they're not Red Hat governed, they're community governed. I told you he would interfere.
It's just me. One of the things, for instance, probably most of you are aware Red Hat has a BPM framework, like JBoss BPM and Rules, the rules engine. One of the other companies that is using the same community upstream or is competing with the offering we have is Camunda. And they are also looking into, they publicly stated on Twitter, hey guys, we're working on an extension for Quarkus. But apparently there was a bug, and we had some interaction with them. So it's definitely not just Red Hat that is providing these extensions. Actually, I'm inviting all of you, if there's an extension missing, at least make a feature request. That's the smallest thing you could do. But please, if you have something and you build something and you want to share, please do. We always welcome contributions.
Absolutely, yeah.
Give the manager.
It says raffle, this one. So maybe this is actually adds an extra point to your name when we do the raffle later on. I'm not sure. But yeah, but I understand where you're coming from, because a lot of the frameworks that are listed here are actually frameworks that exist within the Red Hat ecosystem, like Hibernate and Camel. And those are obviously the ones that we have most influence in and that we can most easily build an extension for. But there's no way that we will not accept an extension that is for something that is outside of the Red Hat ecosystem. In fact, we really, really want to have those. And if you look at the speed with which the Quarkus community is growing, I'm pretty sure they will come. There we go, another question. You only get one chocolate.
I'll give this one back. So, how hard is it to make an extension?
From what I understand, I think there's a video on YouTube with someone who explains to a certain extent what you need to do to get to build an extension. If you're a decent Java programmer, I imagine it's not rocket science, but it's not something I would do. Let me put it that way. Is that enough? Only one chocolate. Okay, now let's move on. So the odd thing is that if you look at the change in programming languages over the past couple of years, Java has been around for a couple of decades, right? And over the past couple of years, there were multiple new languages introduced, like Go, and I just mentioned Rust before. There is Node, and they're all languages focused at doing a little bit of server-side work and to be really, really efficient. And I've heard people mention that Java's dead and Java doesn't matter anymore, and Java's too big anyway, and who needs big application server? And I think over the last couple of years, I think that trend basically broke. Things like microprofile and especially Quarkus change that around and they make it really, really viable to write cloud-native, really small, really efficient applications in Java. So you don't need to learn a complete new language anymore. You don't necessarily need to learn Go unless you want to. and to write a microservice or to write a function or something that runs on Knative. You can actually do that with Quarkus really well, and I'll show a demo in a couple of seconds. So I already referred to this a couple of minutes ago. If you look at where we are in terms of extensions that are added to Quarkus, there seem to be a lot that are from within the Red Hat ecosystem. And there's Vertex, there's Hibernate, et cetera, et cetera. That is also because when the Quarkus project started about a year ago, it's very, very young. A lot of the experts inside of Red Hat from these various projects came together and started building Quarkus back in 2019. I think the first mention of Quarkus was around Red Hat Summit in May of 2019. And at this point, and that is considering the maturity of the code Quarkus has been delivering, as opposed to how young it is, we have, as Roel said, we have customers running on this already, because it offers so many huge benefits as opposed to the large traditional Java stacks. We have, I think it's Vodafone Greece, right? Basically, they're building all of their stuff in Quarkus now because if you imagine you want to run everything in a cloud, right? And you have the overhead of a full-blown application server. And your whole application server eats a couple of 100 megs, and then your application eats a couple of 100 megs. And for every instance of that application, you're basically consuming a gig of memory. I don't think that's really extreme. It might be a little, but it's not really extreme. Now you want to scale that up. You're a big company like Vodafone. You want to scale that up tenfold, 100-fold. You're instantly consuming 100 gigs of memory. Now do that in Quarkus. And I'll show you a couple of graphs later on. But it's not just a matter of it starts faster. It's a simple matter of economics. Consuming less memory and less CPU cycles in a cloud is simply cheaper than using a lot of CPU cycles and a lot of memory. So I think that is an interesting ongoing event, ongoing process. When we look at Quarkus from within Red Hat, we identify 3 major benefits of Quarkus. It saves you a lot of money. And I was referring to that earlier. It consumes a lot less memory. It starts up incredibly fast, so you can scale down further. Then it gives you a lot of cloud efficiency. You don't have to learn a whole new language to do this. You don't have to learn Go. If you're a Spring developer, you can use Spring, whatever. It's all fine. By being close to what people already know, you can start using this really, really fast and get really fast time to market by this. You don't have to learn something new in order to bring new features to the market really quickly because the framework is close to what you already know. And that gives you an edge when we're talking about delivering new services on the market, about remaining competitive. From the developer point of view, from your point of view, hopefully, we identify 4 main Quarkus technical benefits. The first is this is a container-focused language, so it tailors your app to either run with GraalVM with the native binary, really, really small. And if you can't do that yet because you're not using it, you're using an extension that's not completely finished, or it doesn't really work well, or you're using a library there's no extension for, or you don't want to use GraalVM, there's all valid reasons. You can still use Hotspot, and it will still be more efficient than what you're used to. Fast boot time, low resident set size, so container-first language. I will show a demo later on about what we refer to as developer joy. Quarkus gives you, who has done Python programming? Okay, so Python or PHP or whatever, you can just code and you refresh your page and your change is there, right? Quarkus does the same thing, but then for Java. I can change my code, I can refresh, I can do a new API request or whatever, and my application is instantly reloaded, and I can see the new version of my application. I don't have to restart anything. It will happen automatically, and it will happen instantly. So that's really, really cool. You can do that locally on the same machine you're working on. You can do that remotely. Quarkus running on a remote machine, you coding locally, and it will still refresh your page, still refresh your code as you write it to disk. It gives you the ability to write both imperative and reactive language, reactive code. So stumbling over my own language there. It's got a built-in event bus, and it gives you over 90 extensions. I think I said 80 before, but this is growing by the day. I think a couple of weeks ago, we added the whole set of Camel extensions, which by itself is over 30 new extensions for all kinds of integrations you might want to do with Camel. So there is a lot of stuff to cover here, and the first thing, and I promised this already a couple of times, is the metrics. and I love showing these. I'm not really sure what kind of application this was. It doesn't really matter. The fact is that we took an application and we wrote that in 3 different ways. Wrote in traditional cloud-native Java, cloud-native stack. I think it's fairly safe to say this was probably Spring. Ended up with it. I just did. I just said it. Ended up with a 218 megabyte resident set size. We did it with Quarkus. We used the OpenJDK to run it, so it's not Growl. Ended up with slightly over half of the memory there, slightly over half the resident set size, and then we compiled it to a native binary, and then the resident set size is only 35 megs. So that brings down the memory footprint of your application significantly. You can run the Growl VM version of your Quarkus app about 8 times in the same memory space as the traditional cloud-native stack that we have on the right. Any questions about this over there?
Graal VM, according to the developers, Oracle, it's still experimental and they don't suggest
Yeah.
use in the production.
Mhm.
Have you, do you know any progress on that, or still you have any experience on it?
I know we have a lot of discussions there, but I would be a little bit reluctant to say that we are saying that you could use that in production if the developers say it's not possible.
But on the other hand, there are customers that
Right.
using it in production anyway. Actually, if you look at and you have did you pull it out, the slides with the people that are using this in production already, or is
Not
it still
sure.
in?
I can show it.
If it's not in, then we'll show it anyway. But if you look at the ones that are in production, about 6 or 7 at the moment that we can publicly speak about. Half of half, right? Half is still using the hotspot OpenJDK version. Half is doing full native with Growl. Again, it's kind of the similar like. Probably all of you are using Spring Boot, but who's paying Pivotal for support for Spring Boot? I don't think a lot of you do, which is annoying for them, but it's for a story of a life. So this is where it gets a little bit hazy, and maybe not all features are covered as good as it is, but it's as good as it gets, and the benefits are huge.
And is that OpenJ9 VM?
Sorry?
The Quarkus plus OpenJDK? It's J9 VM or
it's
just
regular.
Yeah.
Just a regular.
There was
Yeah.
a recent post on J9 with I think both Quarkus and Micronaut. It does make a difference to the memory, so it should be around 100 if you compare it to this, because it is more efficient than the regular OpenJDK.
Yep.
Yeah, you need to repeat that.
I think the remark was that there was a blog post not too recently, of not too long ago, where there was a comparison made between standard JDK and J9, where the memory usage for J9 went to 100 megs instead of 130. That was about it? Ish, yeah, was about it. Okay, would be interesting. I've not seen that. Have you seen it?
No.
Okay, would be interesting to read.
Yeah.
Just to give you a bit of an idea, and we can take a look at this in a second. You can try this out in your own sandbox later on. But if you look at startup times, traditional cloud-native stack, it's about 10 seconds. If you just use Quarkus with JVM, still starts in 2.5 seconds, still almost 4 times faster. And you can actually start the Growl VM created native binary in a couple of milliseconds. This 0.05 is actually, it's not that impressive. You can actually do it faster.
If you don't mind, I have an anecdote on that one. When Quarkus was still in an internal Red Hat project and we were still kicking the tires to see if it was valuable for all of you to use, one of the things we did is a live demo for an internal crowd just to see what it was. And one of the things they did is they showed boot time. And the boot time said, in both scenarios, said 2. Just after looking a little bit further, one was in milliseconds and the other was in seconds. So we actually asked them to change the boot time to represent seconds, just that you could see the difference. Because in live demos, you don't really see this difference between an MS and an S in your boot time. So
yeah. Okay, pretty good.
Is there a rewrite also involved in converting an application from, say, from the right-hand side to
to the left, do we need to rewrite also the application?
Yes, I would. Well, not necessarily. Depends on your application.
So it's say a traditional Spring Boot.
If you're,
say
yeah, there's a little help if you're using the extension. If you're using the libraries we have extensions for, there's a little help there, but that might not be enough.
Yeah. So as I said in the Spring Framework support slide, we are implementing the annotations that you can leverage the same annotations and use the same naming, but under the covers it recompiles those to the proper microprofile annotation for it. So you cannot take an application written in Spring Boot and just recompile it to Quarkus or GraalVM. That's not possible. We're working on it, but not possible yet.
Good question.
So you missed out.
Yeah, did he? Sorry. Last one. I'm giving away hours, by the way.
Yeah, no worries.
There you go.
I'm fine on you.
I'll get some more upstairs.
Oh, cool.
I'll give out yours.
Big box.
Anyone have a key?
I think there was another question over there. Yeah.
Yeah, I was wondering, with the question coming up with that you have already a Java service or something else and you want to put it up in Quarkus. How is it coming up with plugins like in IntelliJ or Eclipse or whatever EDA you want to use?
Oh, so this is a funny discussion. I'm actually, as I said, I've never been a professional programmer. So if I do some programming, I tend to use something that's called VI. And everybody just looks at me and is like, what the hell? It's what I use, it's what I'm used for. Even when I use IntelliJ, the first thing that I install is VI key bindings. So I might not be the best person to talk about this, but I've been looking around and there are plugins for VS Code. There are plugins in the works for IntelliJ, I'm assuming, because that's kind of a Red Hat thing. We have stuff for Eclipse as well. And those are generally things like, I want to be able to add an extension to this project. I don't want to go into the POM. I'll just give a command in VS Code and it will add it for me. I want to start a new project. I will just start this extension and have it do all the boilerplating for me. And that's basically built into editors already, most of them. Into Eclipse probably as well, right?
Yes.
Yeah.
Very much.
Yeah.
Do you have one in particular in mind?
I'm using IntelliJ myself, so I would love one for IntelliJ.
That actually exists because I tried to teach myself to use an IDE, so I'm sure it exists in IntelliJ. I've seen it.
And you will using Eclipse in the
Yeah. So, moving on. One of the things that as a starting Java guy, one of the things I really liked was the fact that Quarkus allows you to just start up the application, change code, make a request, and have the application recompile real time and show you the result of the new code instead of the old code. And there are a couple of things that are really, really nice to make your life as a developer a little bit easy. If you generally, imagine you make a typo somewhere. And you get a stack trace. You get a 15 million line stack trace. Where's the actual error? At the bottom, right? You scroll all the way to the bottom, that's where the error is. Quarkus turns it around, the error is at the top. So if you have the website, you open up the Quarkus application, port 8080, you open up that application, there's an error there, it will show you the error at the top. It's tiny things like that that make your life just a little bit easier.
We got 2 minutes left.
Really?
What we wanted.
Oh, okay. Damn. Okay, so skip on this one then. Quarkus allows you to do reactive and imperative programming in the same application. We ship all of the required dependencies you need for this. You get the Vertex stuff, you get the built-in event bus. Basically, you can just pick and choose whatever it is you need to build your use case. It's very, very easy to use. You don't have to learn anything new. You just get started with your current skills and start being, I dare say, more productive. And then I will show a list of this later on, all of the 90 extensions we have. There's a pretty large part of the, just put them on the floor. This is not a big box, it's a tiny box. Kidding. True. Fair point. Anyway, so there's an incredible amount of Java-related projects that already have extensions in the Quarkus ecosystem as well. Basically the only thing you have to do is just add them to your project and start using them. There's nothing special that you need to learn. There's nothing different from where you would normally use them. I think this probably makes sense to call this a day for now, unless there's something really important that I missed, and just show you a couple of things before we do a little break and then we start playing around with this ourselves. Is that good?
One chocolate thing.
One chocolate thing?
The chocolates with raffle on it, Natalie wants them back.
Anything
Oh.
anything is written on the chocolate, please give it back. 'Cause
These are pristine. Sorry about that. Yeah.
Something like that.
you might win, who knows?
I have a very quick question.
Sure.
So, it's about Java tonight, but I peeked around the website and I saw there's even other languages supported.
Yeah, well,
Kotlin or
yeah.
Scala or
Correct. Now, let me just start off with that straight away. It's actually a really good question. I'm going to leave the rest of the presentation for what it is because, we're running out of time. But it's a really interesting question you just asked there. So if you want to start off with writing a new application using Quarkus framework, you go to code.quarkus.io. And basically you can generate a lot of the boilerplate here and just download a zip file or a tarball and unzip that or untar it on your system and start coding straight away. As an example, let's just say I want to start writing something that uses my group here. Let's call it GOTO night, right? GOTO night using Maven. We do support Gradle as well, but I think Gradle support is a little bit rougher still than Maven support, so Maven is recommended. And the only thing I need to do at this point is just select stuff. And going back to your question, we do have support for Scala. And is this readable in the back? Probably not, right? Zoom. We do have support for Kotlin Scala as well. I'm not sure if you've seen anything else. This is what I know of. But there are different frameworks that are being enabled as we speak. Yeah, correct.
and the support is complete. It's 100 feature on par.
Well, it says preview. So I wouldn't go as far as to say calling it complete, but we're working on it. Yeah. So.
We're looking for pull requests.
Right. Oh, sorry, was another question?
Can I also run Quarkus on React instead of Vertex?
I'm not sure if I understand your question. Can you repeat that, please?
Okay, you said the runtime engine is Vertex, right?
Well, you can't. Yeah.
Can I run it on React instead of Vertex?
Not enabled yet.
No.
So at the moment, the reactive implementation that we tried first is the one that we ship, which is Vertex. So that was done first. There's at the moment not that I'm aware of any other reactive frameworks implemented yet. Again, we're looking at feedback, what our user space is using, and then we'll decide the priority on that one. So yeah, unfortunately, no.
So if you write that extension, let him know how hard it was.
So how do you want to bring the string security? Because the big part of the string security is based on React.
It's going to be the database program over.
Yeah.
So basically all of the Spring support is not actually supporting Spring, it's supporting a similar programming model using familiar annotation. It's not actually bringing in any of the underlying code. It's all done by...
Exactly. So yes, you will be using the same annotations that you're used to, but the underlying implementation will be different.
Because you don't want to bother learning JXRS at get annotation instead of saying at get mapping, for instance. So then I can react to the string security with Quarkus?
Not yet. Working on it.
Right. So let's pretend I'm going to do some JSON stuff here. I'm just going to enable a couple of extensions. This is one I really like, by the way. Forgive me for saying, but I've always struggled a little bit with database connections in Java. I've found them to be a little bit quirky compared to a lot of the other languages I was playing around with. It was a little bit odd. Have you guys heard about panache? I think panache is basically the bee's knees. It makes setting up and maintaining a database incredibly easy. So if there's one of the scenarios later on that hopefully you guys will play around with, and one of them really touches on panache and how panache makes it easy to create a database model and how to set up your database connection, all that kind of stuff. Really give that a go. It is really, really nice. So we're going to play around with panache a little bit. Well, let's say that we're going to use a Postgres database, just enabling some extensions here. Let's say that we want to use, I don't know. Let's say we're going to use Kafka as well. So only thing I need to do is generate my application, download a zip file, and I can get going. So that's really easy. You can also do this from a command line, by the way. There's a fairly simple way to do this with Maven as well. So let's say I'm going bigger?
Yeah.
Is it readable? Try to make contrasty. So, not readable? Okay. So let's say I want to start building a new application. So the only thing I need to do here is run a really large Maven command. This is going to generate some boilerplate code for me based on, let's use 120, 121. And this will generate a REST endpoint for me as well in a greeting resource. So the only thing I have to do is run this. There will be a lot of Maven output. Oh, that's it. Wow. I probably have all the stuff downloaded already. And there's the boilerplate I need. There's a Maven wrapper. There's everything that is... Are you guys familiar with Linux, or am I doing magic here? Basically, this is all auto-generated through Maven. And I can fairly easily just now start up this very simple application. Go compile Quarkus dev. And this is going to start listening on port 8080. We are listening on port 8080. As you can see, we have only REST Easy enabled because this is something I generated through the command line. This is not the one I downloaded from code.quarkus.io. This is the dev mode, so it started in just over a second, which is, it's okay, but it's not fantastic. We can do a lot better than this. But just give you an idea of what this, your VS Code people, right? So, no, it doesn't matter because I'm trying to open this. So this is auto-generated. So from what I understand, this should zoom. No, it shouldn't. It's not zooming. Is it zoom? Oh, come on. It's supposed to zoom. Oh, there we go. Just figure out what the right key combination is. So here, this is on the right side of the screen, there's the Quarkus plugin for VS Code. It helps you set up new projects. So we can do it through the command line, through a plugin in an IDE. You can do it on a website, so it's fairly easy to get started. Right here, I have my application running on port 8080 at the hello endpoint at this moment. That is the application I just generated. Let me always forget how VS Code works. So if I go HTTP and if I call that endpoint right now, damn, I should get hello back. And if I go into this code here and I change goodbye, change the code over there, only thing I have to do is save it. I call the endpoint again, and it now says goodbye. And I didn't restart anything, I didn't redo anything, I didn't have to go Control-C somewhere and restart my application server. Everything was automatic. And what you will see here is that it detected change source files the moment my request came in. It basically stopped the Quarkus application, left the JVM running, did a recompile of my Java code, and then served out the new version of my code in, where are we? 0.447 seconds. So that is pretty good in terms of development process, I think.
So this is class loader magic like JREPL did? Or?
No, this is not JREPL. As far as I know, this is not a REPL. No. This is just a recompile in the background.
No, JREPL has also this reloading that was like 4 years back. I know the Play framework has its own class loader which does exactly the same thing. So I was wondering what technique was used.
Oh, what is happening under the hood? That is something I would have to ask engineering. That's something I really don't know. Sorry. Yeah. Yeah.
I need that.
Yeah. A little too deep. Sorry.
Drop me an email.
Yeah. So the thing is, I think we had until about.
It's Natalie's party.
So. And I don't want to go too far into the time we have for breaks and playing around with Quarkus. So.
It's around now.
Yeah. Okay. I had a ton of things that I just really want to show you guys, but I was talking too much, which is something that happens to me a lot, to be honest, which is why I went into sales, I guess. So let's look at one more thing, at least. I fight with Minikube all the time. What I think is interesting to show at this point is maybe the simplicity. So I get extensions. This is the project I just generated, right? And there's only one extension enabled at this point, which is the Rest Easy one, which is the Quarkus list easy command. I can get a list of all of the available extensions that I can add to my project. As you can see, there is quite a few. And adding them is as simple as just going, let me just go back to the top. I just add an extension, and we pass it the name of an extension, which is, let's just add, I don't know. Let's add Tika, I don't know. Just add it, and that's it. Now, this is obviously a very simple thing because the only thing this does is adding this to my palm. But the simplicity, what this gives you, and basically the ease with which you can see what extensions are all available for you are pretty useful to me, at least. What else can we fairly easily do in a small amount of time? We can build this application, so that is interesting maybe as well. So we can do the compile. I think it's package. Package gives me the jar, right? So if I run package, I get the jar file that is dropped into my target directory. As you can see, there is an automatic test that is generated through the boilerplate generator as well. And it breaks because it gives me goodbye instead of hello. So exactly. So let's revert that change real quick and try and rebuild this. This should spit out a jar file in my target directory. This should work now. And I think it does. And I can just start this up. Let's see how fast this is in terms of starting up. So I can start this. We have the runner. This starts in 1.5 seconds. Meh. So let's try and build the native one. This takes a little while. There's a little bit more work to be done. Doesn't take forever, but it takes a little longer. See, the tests are run during build. If you scroll back, you can see that during build, all my tests are run against a true instance of my program. Sorry, yeah. I will scroll down in a minute. But you will see that the tests are run against a real instance of my project. There is no mocking going on or whatever. It's just the real thing. You can start it up during build. Now, the whole Graal VM thing takes about a minute or so, and then we'll spit out a binary that you can fairly easily just throw into a very minimal container image. And then one of the things that we generally show when we do this, we start a Kubernetes instance in Minikube. We create a container image with this binary in it. We run it in Kubernetes. We run it once. We scale it up to 100. There is no problem whatsoever. I'm going to run 100 instances of this application on my simple laptop in a VM that runs Kubernetes. I fight with Kubernetes, so we can try, but there's no guarantees that this will actually work. And the only reason we cannot go to 500 or whatever is that apparently in Minikube there's a limit to the amount of IP addresses you have. So I can only go to 100. If we could do this in an OpenShift instance on my laptop, we can try to do that later on. I think that limitation is probably gone, and we can go up to hundreds of instances, and there's no problem whatsoever. And that is actually pretty cool. Yeah, still building.
Perhaps you can already redirect him to the training URL.
Well, yes, I could, but then everybody would flip open their laptop and not see this spectacular stuff happening on stage.
I always love a good terminal. I'm in Red Hat. I don't like clicks.
What we can, there we are. So we go back here, and then we can start the actual target. This is the actual native image here. And if I start this, it actually starts in, well, 0.016 of a second, which is very quick. And the reason, and actually we didn't get around to doing that in the deck, but the reason this is so interesting is because imagine you want to scale your application down to 0 and only have your application do something when a request comes in. This is actually a latency you can work with, maybe. If you want to think about seconds, it will never work scaling it down to 0. Seconds is always too much. But if you can work with 0.016, well, maybe that is good enough. And actually, if you run this on decent hardware, it will actually be a little faster. So you can actually spin up your application fast enough to handle traffic, scaling up from 0 to whatever it is that you need in an amount of time that is actually good enough to run your application at 0 instances.
So you're talking about serverless.
Yes, we're talking about serverless Knative. I didn't get around to talking it in the deck, but yeah.
Have you measured the difference between a cold run and a hot run?
No, I have not. And I can imagine, I do think we actually scaled this all the way back to 0. So, it is definitely possible, but the way Knative works is that there are a couple of, how do you call those? There are 2 containers running with the main Knative pod that is scaled to 0 to make sure you can actually run it when the request comes in. There's a name, sidecars. So that is the reason it works, and I'm not really sure if there would be. I'm not really sure. I've not measured it.
So within a normal Kubernetes environment and also OpenShift itself, you cache your images locally on your host as well. So that there will definitely be a difference between a hot and a cold start. But if you look at the minimum image which we ship, which is UBI 31 megs plus your app, you're still talking about seconds work. But yes, I would highly recommend that if you go that route, you do make sure that the cache is warmed.
Can you show the size of the binary?
Oh, sure. Yeah. Let me.
Human?
It is, sorry. It's about 29 megs for people in the back. So the binary is 29 megs. Just for fun, the jar is 200, and that's not entirely true because I need to show you the other one. The jar itself is really a lot smaller. So it's a combination of the 200 and the 4.6K. So it does drag in a little bit more than the jar. Sure.
So, what's the catch? What kind of what kind of application would you want to build?
Generally, how we position this is for back-end applications, APIs, that kind of stuff. If you're really writing, if you're trying to rewrite your monolith in Quarkus, that's probably not something you want to do. You could theoretically.
What's the catch? Anything you want to do dynamically, that's the catch.
Right.
If you do aspect-oriented programming, if you do dynamic injection on the fly, basically the whole idea of the framework is to pre-calculate that.
So no dynamic class loading.
Yeah.
So yes and no. If you want the absolute optimized result, then the answer is no. You could use some of those, but then you lose some of the power of the framework, right? It's a trade-off you get. So if you're asking what would be a typical example of not to use this one, either really dynamic behavior, unless you can, calculate that beforehand, because if you can, then obviously you can then do it the Quarkus way again. The other thing I wouldn't do is if you have a long-running, millions of light years application that needs to survive the Third World War, then no, don't go for Quarkus.
So we do, for instance, like dynamic class loading in our application. So we have a configuration somewhere with classes, and we want to create instances of a new class. Would that work?
Yes, but that's normal dependency injection. That's not a problem at all. It's more like in some scenarios I want to go left, and in some scenarios I want to go right, and I want to dynamically determine that based on whatever. Then I would say you have better ways to solve that, but you could theoretically do that with a dynamically class-loaded environment, and you can't with Quarkus because it pre-compiles everything. So that would be a use case I would say. No.
Exactly the same case you have with Roel, we have in general.
Yes, it's a Graal thing. It's not a Quarkus specific thing. Actually, Micronaut has the same thing, and I think Spring started to dabble with this as well. So.
I think we need to call this off and move on to the next bit, much as it pains me. We have this set up for you guys for after the break. Is this the wrong URL?
Yeah.
Okay.
Learn.OpenShift/training.
Okay.